Tomorrow, like I said, you're going to have some practice free response questions. I'm going to let you guys look at this for a second and strategize. What strategies are you thinking we should do?
Two-way table.
I would build a two-way table here. Do you have to build a two-way table? No. Did anybody try to do a tree diagram? Or want to do a tree diagram? Perfect. Okay, so if I'm doing a two-way table, I have two variables. Did the people read USA Today or not? And did they read the New York Times or not? Tell me everything I know.
Read the New York Times.
So that would be my total for the New York Times. What does that mean the total for not reading the New York Times is?
75.
What else do we know?
45%.
45% read USA Today. So 55% do not.
10% read both.
Seems to be working out. All right, now, if we want to know if it's independent, we need to find two probabilities. Which ones do you think we need to find? You have two sets of options here.
Probability of reading the New York Times.
Okay, if that's the one I'm finding, I need to compare that to the probability of reading the New York Times, given that they also read USA Today. So let's see, that would be 0.25 and 0.1 over 0.45, which is 0.22, repeating, I think.
Yeah.
So are they independent?
Yes.
Are they the same?
No.
So are they independent?
No.
They have to be the same number. In order to be independent. Are they close? Yeah. And in broad perspective, maybe. But for right now, for our purposes, unless they work out to be the same thing, they are not independent. Okay. I do want to talk about one more thing. Kind of make a connection for you guys here. Do you guys remember talking about the probability of A and B is equal to the probability of A times the probability of B given A has occurred. Is everybody good? Okay. Well, if the two events are independent, so this next part only applies to if independent. The probability of A and B would equal the probability of A. Well, if they're independent, B given A is equivalent to just B on its own. And the reason I'm pointing this out is using this rule would be a lot easier on this particular problem. Because we could say, well, we know the probability of A and B was 0.10. We were given the probability of A was 0.25. The probability of B is 0.45. And if I multiply those out, I get like 11 and some change. I think we get 0.1125, I think. I'm doing that from memory, not from brains. So are these two things equal? So it's just a different rule for checking independence. Whereas if they were independent, it would work out that both of those things ended up being the same thing. Okay, I'm done for today. Tomorrow we're going to do more practice. All right. So random variables. I want you guys to, let's start with the opening thing to think about here is we have 3 coins and I flip 3 coins. Is everybody with me? What are my possible outcomes? Let's make a tree diagram of that real quick. The first coin could be heads or tails. The second coin, heads, tails. Third coin, heads or tails. And if this is a really efficient way of coming up with our sample space, but I'm just going to also write out what each of those branches means. So it would be heads, 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 tails, heads, tails, tails, heads, tails, heads. You're not doing the puzzle while I'm talking, yeah?
I'm not. That's what I'm thinking of Hubert. That's when you said H, H, H. That's what I'm thinking.
Oh, Hubert Humphrey.
Hubert Horatio Humphrey's middle name was first.
Everybody good? And which of these 8 outcomes is equally likely? Or is more likely than the others? No, they're all equally likely. Is everybody with me? Okay, so if I define my outcome as where the order and stuff is important, they're all equally likely. Okay? Where we're pushing into when we deal with random variables all have a numeric value. So I could assign to this first one 3, the second one 2, the third one 1, 2, 2, 1, 1, and 0. Does anybody want to guess how I assigned those numbers? It's the number of heads. All right, is this it's been a while since we talked about discrete and continuous. A reminder, a continuous variable might be the length of your foot, whereas discrete might be your shoe size, where you can't have any in-betweens. Can I flip 1.25 heads? No. Okay. So this is anything that is a number of anything is always discrete, because if it's counting, you can't count the halfways. Okay? All right. So in some respects, if instead of letting x be these different orders, I'm going to say, let's let x equal our number of heads. And so what would my possible outcomes be? Well, I could have 0 heads, 1 heads, 2 heads, 3 heads. Are all of those outcomes equally likely? It's a probability I don't get any heads.
1 in 8.
1 in 8 or 0.125. So probably I get 2 heads or 1 heads. 3 and 8.
Yeah.
Because there's 3 different ways that could happen. Are we good? And we can kind of just go through and we can count each of these things. So while each order is independently equal to each other, equally likely, the number, because there's more ways to get 1 or 2 heads than there is to get 0 or 3, we end up with different probabilities. So far, are we feeling okay? All right. Now, we started about thinking about probability is how frequently something happens, which means we can draw a histogram of a probability distribution. Okay? So if I let my x-axis be my number of heads, and I let my y-axis be the relative frequency, I could have 0 heads, 1 heads, 2 heads, 3 heads.
Wait, why is 0 like off?
Yeah, I don't understand.
Because it's a whole bar in and of itself.
Oh.
Are we still feeling okay? And in a large number of trials, this is what we would expect to happen. Are we good? The histogram, yeah? At the very beginning, like in Unit 1, if I gave you a histogram and asked you to describe what you see, what were the things you needed to describe? Shape, center, and spread. What's the shape? I would say it's pretty symmetric, yeah? In fact, definitely symmetric, so it's not skewed. Skewed would be where you have a lopsided tail.
Yeah, I thought there was like another thing on the right.
All right, so we have I'm gonna say no to normal because it's really hard for a discrete variable to be normal, and while it's approximately bell shaped, it's really too discrete to really tell. We only have 4 possible outcomes. Like, think of it this way. If we found the mean and the standard deviation, that 68, 95, 99.7 rule would not apply it would be too wonky.
I just forgot that it was called symmetrical, not normal.
Well, normal distributions are symmetric.
Yeah.
And I would call it unimodal. It's still like at a peak and it's symmetric. And not in this one because it actually is perfectly symmetric. You guys, what's the mean?
1.5.
So the mean is the right? Like we're not talking about the mean of the probabilities. We're talking about the mean of the number of heads. You guys, is it okay to say that on average you get 1.5 heads? Yeah, because you're talking about an average. Everybody good? Okay. And for the spread? I would use the range, which would be 3. All right. Imagine Miss Meister is trying to make some money before the holidays. So she's going to challenge students to a game. It costs you $1 to play. Don't worry, I accept Venmo. Okay. And so, really easy game. It's a spinner that has 2 blue sections, 1 white section, and 1 gray section. So, for right now, all we need to know is what is the probability you land in the white section. Not meant to be a challenge, guys. We got this. What is it? 1/4 or 0.25. The gray section, 0.25, blue, 0.5. So, like I said, I want to make this about money because I'm trying to earn some money, okay? So, here's how the game's going to go. If it you cost you $1 to play. And if you land in white, not only do you get your $1 back, I give you another $1 back. Everybody good? So, overall, your gain would be $1. Because at the end, you are up $1. If you do the spinner and it lands in gray, you get your $1 back. So your gain would be $0. If it lands in blue, I get to keep your $1. So your gain would be -1. Now, if your gain is $1 when you land in white, what is the probability that you walk away from the game $1 richer? I'm sorry?
If you said if it lands in white.
That's when you walk out with $1.
Yeah.
So what's the probability that you walk out with $1?
0.25.
0.25. You got to land in the white, yeah?
Oh,
What's the probability that your overall gain is 0 and that you break even? What's the probability that you lose $1? Is this every possible outcome? And its probability. The spinner, just spinning the spinner is just like a random event. The minute we attach these values to it, whatever those values might be, okay, then it becomes this concept of a random variable, where it's a numerical value that represents it, okay? All right, so it's every possible outcome, and the way I know it's every possible outcome is the 0.25, all the different probabilities add up to 1. Okay. Would you play the game?
No.
I would.
Sure. I mean, it's $1, yeah. That was like $50. I'll play once.
Because the money's going to me, you win it? Is that what you said?
I mean, it's $1. Like, I'll spin it.
You guys, I love this reasoning. Keep it coming, right?
If you need money, I just give it to you. You just.
I'm not, you guys, we're not really going to do any, it would be highly unethical for me to gain money off of you guys. It would be really bad. It's not going to happen.
Wouldn't it be smart, like, wouldn't it be more like better for your money to, if it was a larger amount first, because the more trials you do, since it's 0.5, the higher likelihood it is that you lose money. Since it's a 50%.
You're gonna lose more money if you bet more money.
Losing money, so.
This is just
Yeah,
a heads
but that was
up.
what.
It's the same thing.
No, it's not the same thing.
Wait, oh no, you're right.
Because I don't have to pay you the same amount of time with the same amount of frequency that you would have to pay me. Yep.
Yeah.
Yeah, but you don't lose money if you or, I know, but I'm saying it's a 50% chance you don't lose money. Right?
You have a 50-50 shot whether or not I keep your dollar, sure.
And 25%.
Oh, no.
and there's 75%
I'm
chance
just
of
saying,
not
like,
making it.
odds-wise, it's, like, actually not even better either way.
Okay, so we should talk about this because there's a whole
Just don't.
industry. There's actually several industries, but a whole industry that relies on you thinking that you should play this game. And they make a lot of money in it. It is the gambling industry. Okay, great. They actually hope that you're like, yeah, it's only $1. Because now imagine every student in the school says, Miss Meister, it's only $1.
It's 400%.
Let's say there's 400 people in the school. Let's play it out. Let's say 400 people in the school. Do you guys think the probabilities will hold? Is that a large number of trials?
More or less.
Okay. So if we have 400 people in the school that play this game.
Wait, but you'd have to pay some of them back. So
Okay. All right. So let's start with how many people will walk away with the plus $1? 100. So if that were the case, Meister would be out $100. Yeah. How many people are going to break even? 100, give or take. We're all comfortable saying that this wouldn't be perfect. Yeah. Why is Miss Meister out? Oh, and if this is Meister, this would be a negative 100 because I'd be losing it. Yeah. How many people are going to lose $1?
200.
So you're absolutely right. I'm going to have to pay some people back, but I'm still walking out of here $100 richer.
I don't care. It's still only $1 to me.
This is what
But that's the gambling problem because you just keep going.
100%. This is why Miss Meister doesn't
I
gamble.
guess the church fair every year, they get those teenage boys together. And they
Yeah.
just keep going. And they're like,
Yeah.
well, I made $1, might as well make some more than I lose it all.
100%. This is the mentality that they're hoping you follow when you go to a casino, when you play the lottery, which you guys, when the jackpot gets really big, Meister heads the lottery for the school. Like, and I know it's not, like,
Wait, what?
when either the Powerball or the Mega Millions get really big, the whole staff will like go in together and get a pool to buy extra lottery tickets. Right? And then if we win, we split the pot.
Have you
It-
ever won?
No, never.
I think
Nobody-
I would know.
nobody-
It's so slim. It's
Oh, for sure.
crazy.
For sure.
You wouldn't be here yet.
But when it happens, I'm the one that organizes it.
So do you make more?
So,
No.
if you,
Your name will be on all the tickets.
so if
Correct.
You,
And none of the other tickets.
if you guys
There's
win-
plenty in writing that I would legally be held responsible, for sure. I do it all over email. I would definitely be
You
legally
have to pay
responsible.
all the taxes. Wait, how many staff?
No,
members are
it wouldn't
there?
work that way.
How many staff members are there?
Roughly, we end up with about 40 tickets each time.
So,
So
if
how
you
many
all
people?
won, would they have like a massive staffing problem in the school?
I would imagine it would be a challenge,
How
yeah.
much money does it like get up to? But then with taxes, how much do you really get?
The last time we played, we would have each walked away after taxes with somewhere between $5 and $10 million. We don't do this every day. We only do it when the jackpot's really big. Tomorrow. Well, so you guys. So how much am I making per game?
$1.
No. How many people played? 400. So if I wanted to find my average price per game, I would be up 25 cents per game. On average, I'm going to make 25 cents for everybody that plays. Not on any one person, right? Because one person is a small number of trials. But for a large number of trials, that's what's going to happen. Okay. So we're going to really talk about this a ton tomorrow with this concept of what we call the expected value or the mean of a probability distribution. Okay? When the mean of a probability distribution is positive, then it makes sense necessarily to play. Then you might be more willing to play. That's what makes me willing to play a game. Never changes the probability of winning, but the payout is big enough that I would consider it. That's kind of how I think about it.
Aren't the odds like